Good morning, this is your Stat Sensei, Mr. Spensei, and this is an assignment on regression, specifying on calculating regression statistics and calculating residual plots. And here we go. The scenario is wine good for you? A researcher collected data on the average per capita wine consumption and heart disease from a random sample of 19 countries. So we have 19. There appears to be a linear relationship indicating that wine decreases heart disease. Use a table to answer the following questions. All right, so first off, let's go back and make sure we have everything turned on. We're going to go to mode, and I'm going to scroll down to stat diagnostics, make sure that's on and highlight it. And I definitely want to be a stat wizard, so make sure that's on and highlight it. Once you have that, you can blue quit. All right. And we're going to go to stat edit, and I'm going to enter all that information in there. All right. And by the way, at the bottom, you notice these X bar equals. What that means is if I go back and go stat calc one variable statistic L1, I go, oh, I have a check figure 3.026 and 2.509. I want to check the other one, stat calc one var stats, changes to blue 2. So now I have 191.05 and I have 68.396. So that's where those values are helpful. We don't input those in the calculator. We're going to just do these 19 values, and we have them in L1 and L2. All right, as soon as we have them in L1 and L2, we're going to go ahead and run the regression tests. So stat test linear regression t-test, which is letter F. L1, L2, frequency we leave alone. We want it to be not equal unless there's a weird situation, that'll be not equal. This is really odd, but we're going to press the alpha button, which is a green button, followed by trace. And then we'll just press enter. And we get a whole lot of information. All right, there's our t statistic, our p value, degrees of freedom. Um, and please note, A happens to be our y-intercept. B is our slope. And I know that's really weird, but the way to keep in mind is what you learned in Algebra 1. You learned it this way. You said y equals mx plus b. The m was the slope and was always next to the x. B is our slope because it's next to the x. Okay, so, and the other value is our y-intercept. So in this case, our y-intercept in this case we see is 260.533, and that's the very first thing it asked for. The next thing it asked for was our slope. And like I said, slope is always next to the x, and our slope is negative 22.9687. The next thing it asked for is our coefficient of determination. Well, I don't see that, but if I scroll down, I get my r squared. R squared is my coefficient of determination, which is 0.7103. It's often written as a percent, 71.303% or 0.7103. Either one is correct. And R squared will always be positive. The next thing will be our correlation. Well, I know because my slope is negative, I know that my correlation is going to be negative. If I scroll down one more, there's R, and there's my correlation, and it happens to be negative. Now, we'll come back to that in just a moment. The slope was negative, so my correlation was negative. And the last thing it asked for is the standard deviation of the residuals, which happens to be S 37.785. So that is as well. And so that standard deviation of residuals comes straight off the calculator. I want to go back to the correlation coefficient. So back to the correlation coefficient. Correlation coefficient is made out of two things. It's made out of sine of the slope and the square root of r squared. Well, in this case, our slope is negative, so we have a negative slope. And we're going to take the square root of our coefficient of determination, or r squared, which happens to be 0.7103. So let's try that. Stat, oops, 0.7103. 103. And I always just raise it to the half power. And we get 0.8428, which is exactly what we had there. So sine of the slope and the square root of r squared. Please keep that in mind. That's going to be really important. All right. The next thing it's going to ask us for is the regression equation. Well, let's go back and I'm going to run the test real quickly. Stat test, linear regression t-test, all the way through, alpha trace. It's a plus bx. Well, what was a? 260. Now we always write this as y hat. So we're writing it basically as y hat equals, well, what was a? 260.56. And then it asks for b. What's b? Negative 22. So minus 22. If we've been positive, we put a plus sign. Minus 22.96. And then the next thing we'll put an x. Now, that's technically correct. And this is my y-intercept, and this is my slope. What's much better is to define the variables by going like this. Well, what we're looking for. L1 happens to be our x's, and y, L2 is our y. So here we go. Death rate. So I'm going to put death, just to shorten it up. Death equals 260.56 minus 22.96. And then I'm going to put wine consumption or alcohol. Specifically wine, but it's alcohol consumption. Now, by doing that, I've defined my variables and I don't have to do that later because you'll find out later that we have to do that. So this is technically correct. But if you do that, you're going to have to define your variables. If you do it like this, you don't have to define the variables because they're already done for you. Okay, the next thing it asks for, expected death rate for 0.8 liters. All right, so to do that, I'm going to go, okay, where's 0.8 liters? 0.8 is right here. And so I'm going to go to my calculator and go and plug in, take my equation, the y hat equals 260.56 minus 22.96 and plug in 0.8. So let's go ahead and do that. 260.56 minus 22.96 parentheses. And I end up getting 242.1883. All right. So that's the expected death rate for consuming an average of 0.8 liters. On the other hand, let's see what the death rate is for 7 liters. Well, once again, I'm going to take my original equation right here, and I'm going to plug in 7. I'm going to go y hat equals 260.56 minus 22.96, and I'm just going to plug in 7 for the x. So 260, I'm going to clear that so you don't have to see it. 260.56 minus 22.96 parenthesis 7, and we end up getting 99.84. So that's where that comes from. Okay. And by the way, that difference is due to rounding, right? But all we did was we plugged in this value for x and this value for x into our equation right there. The next thing says calculate the residuals for the amount of wine consumed. All right, calculating residuals. Best way to do that is go run your test again. So stat test, linear regression t-test, alpha trace, All right. Now we're going to go to Stat Edit, and we're going to go to the top of L3. And we'll press the blue button and then the word Stat. And we see the word Resid. We're going to highlight that and press Enter, and then our residuals popped up. So it says calculate the residual for 1.2. Well, 1.2 happened to be the very last one. So if I scroll all the way down to 1.2, I end up getting a negative 34. All right. The next one says, hey, do it for 2.9. So I'm going to scroll all the way up till I get to 2.9, and there it is. And at 2.9, I end up with a residual of 26.046. Then I'm going to drop down to 3.9. Oh, we have two 2.9s. Oh, we have two 2.9s. So there's actually two different answers. And either one of those would be correct. 26.046 and negative 62.95. Both of those are correct. And we won't do that to you on the test. 3.9. So 3.9, we only have one, and we have negative 3.985. All right. Then we drop down and it says, hey, let's do it at 5.8. Well, 5.8 is way down here. So I'm going to scroll way down until I get to 5.8. There's 5.8. And my residual is negative 12.34. Then it asks for 6.5. 6.5 is up a little bit. There it is. So my residual is negative 25.27. And the last one it asked for is 9.1, which is a little farther up. So we're going to scroll up to 9.1, and we end up with a 19.452 as our residual. Okay, so that's how you get the residuals. And I'm sorry that that particular one had two of them. All right. Next thing it says sketch the scatter plot. Well, I go press the blue button, stat plot, enter, make sure it's highlighted as on. Turns out the first one, we want the first one. And our X list is an L1, our Y list is an L2, so blue 2. By the way, to do this is blue 1. And now we can press zoom followed by the number 9. And we end up getting a scatter plot that looks like this. I personally like to show my regression line, even though it didn't ask for it. But this is the predicted line. All right. And I just kind of sketched it there, but that's the predicted line. And it helps me put the graph in the right spot. And then the next thing it asks for is to sketch the residual plot. Well, to sketch the residual plot, I'm going to have to go back into stat plot. So blue button above it, press enter. Everything stays the same except we're going to change the Y list. Well, let's go back to stat edit. Our residual is an L3, so we're going to go blue stat plot and change the L2 to L3. So blue 3, follow zoom 9, and there's our residual plot. All right. Now, if I look at that residual plot, I go, you know what? I kind of starting to see something that looks like this. All right. So it says, is a line appropriate? Justify your answer. And it's like, no, a line's not appropriate because I'm starting to see it get closer and closer. It's starting to get closer to the line. This is actually known as homoscedasticity. This is homoscedasticity says that the variation remains the same. But look, I have a whole lot of variation and now I'm getting less and less and less. So I expect to get, the way it looks like I'm getting closer and closer. So there appears to be a pattern. For a line to be appropriate, the residual plot must be random. This is not random. There is a pattern, so a line is not appropriate. All right, I appreciate you watching. Look forward to seeing you on the next one. Thank you.